Hello and welcome to GG on Air, where we take a journey through Amazon Web Services to strip away the technical jargon and talk about some of the strategic thinking behind AWS technologies and services. Kicking off this podcast series, I thought of talking about something close to my heart. This is, in fact, one of my favorite announcements at the last year's reInvent. Yes, and that is, let's talk about EKS Auto Mode. So, joining with me today is Zach, who's an AWS hero and very well known among AWS community in New Zealand and all over the world. Hi, Zach. How are you?
Hey Geetika, how are you? I'm doing good. How are you?
Good, good. Thanks for joining. Before we dive into today's topic, I know you keen to talk about EKS and EKS Auto Mode, but yeah, before diving in there, tell us about what you do in your day job.
Cool. So, as a day-to-day job, our team, like including me, we manage multiple EKS clusters. So it's basically a platform. So we enable the customers to easily deploy, manage, monitor their workloads, and run their workload. Not only APIs, there are some GPU workloads, and so on. So we are there to improve, upskill the clusters, and upskill that overall the platform service and troubleshoot, because running a cluster and multiple clusters are not easy. So every day we had to do cluster upgrades, add-on managements, migrations, and so on. Right? We can talk about entire about EKS.
EKs, yeah, yeah. So actually, that gives us a good starting point. Why
Yep.
do we need EKs? Because every time when I face with a customer, so that's the first question I ask: do you really
Yep.
need EKs? So, in your opinion, what do you need EKs?
So before we go into EKS, let's say why Kubernetes? Why, even though if you tear it down, why containers, right? So containers very easy to um, platform independent. So you don't have to worry about your underlying of your the operating system or anything. Just you can containerized your application and just push your application in high velocity. Forget about the rest of things. So Kubernetes itself, like it's basically orchestration of containerized platforms, right? So it's one of the platforms in the industry, and EKS itself managing a Kubernetes cluster. It's not easy work, right? Like, have you heard about this hardware of Kubernetes? There's a repo that you can learn about. So when I was initially learning about Kubernetes, I went through the same repo. One of my good friends referred me that, okay, you should try this out, and then we can then you will understand about Kubernetes very well. So managing a cluster, it's not easy. There are multiple components, right? Control plane, data plane. Under the data plane, there are add-ons, so much things, and the control plane itself, the API server, HCD database, so much things. So main pain point is managing the control plane, I would say. So EK is a good option because it supports so many things. And you have noticed, right? Not only this auto mode, pre-reinvent and post-reinvent, so many announcement about Kubernetes. Like they have introduced the upgrade insight, so you can see any insight before you upgrade, so on. So EKS comes as a out of the box full platform for your Kubernetes support workload. Just you can deploy in hosting AWS cloud and supporting many other
Yeah.
services.
Yeah, I think you touch a very good point because from Kubernetes to EKS, it is taking away that management of the control plane because
Yep.
AWS takes care of that within
Yes.
EKS. So I think so. Then it gives us a premise to today's topic, EKS Auto Mode. So again, before going to EKS Auto Mode, what are the challenges you face in your day-to-day EKS cluster management?
I would say mainly the scaling part of it, like the node scaling, I would say, and the add-on management also. So right, keeping the add-ons up to date, and the main challenge I would say, not only including me, myself, everyone, even you, cluster upgrades are really really challenging part of day-to-day work.
Yep. So how does EKS Auto Mode helps in there?
Cool. So EKS Auto Mode. So before we dive into that, let me share my screen. This is the traditional EKS cluster, right? So you can see we have the cloud, and we have the EKS cluster. So EKS account side, you see manage control plane, which is managed by the AWS team. AWS, we are getting the API server instances, etcd instances, and we can't see those things right in detail, but we get the control plane when you go to the Kubernetes. Sorry, when you go to the AWS console, when you create this, when you create an EKS cluster, by default automatically behind the scene it create all these things. But custom account, it's in our account, we have to take care of these main components like the data plane, right? So the main part, add-on. You need to have these basic add-ons to run a cluster. So for example, there are multiple add-ons in this slide, but I would say VPC CNI, a CNI plugin, Kube proxy, and the core DNS. Those are like key plugins to you need to run a container. Without this, you can't even spin up a pod. Like you can't just run it. So apart from that, for the ingress, or if you want to get the ingress out of your service, you need to have a load balancer controller. So AWS, we have the AWS load balancer controller, or else you can install something like Nginx controllers, Nginx ingress controllers, so on. And pod identity for if your pods want to access like AWS resources, like secret manager, like retrieve a secrets or S3 bucket, so on. And we can't forget about the persistent volume. So we have the persistent volume Amazon EBS CSI drives to enable that feature. And we have the hero here, the Carpenter. So before we go to Carpenter, I think you're familiar with Cluster Autoscaler, right? So that's the grandfather of, I would say, like, still people are using Cluster Autoscaler. So Cluster Autoscaler, it works in a different way, but Carpenter is really intelligent. So it's a big fuss now in the industry, right, about Carpenter, because it's really intelligent to find the correct.
Yeah, I think it is becoming the de facto standard of cluster scaling, right?
Yes, yes. So Carpenter is really intelligent to find the correct worker nodes for your workload. So when you set up initially Carpenter, right, like, you will notice that Carpenter will spin up a couple of nodes. By the time it will scale in and bin pack all of your workloads, and it will save your cost. So there are so many things about Carpenter. We are not going to go into Carpenter today, but we can have another session about Carpenter. So Carpenter will take care of your worker nodes, which are like EC2 instance. So EC2 instance will be managed by Carpenter. And we have in our account, so when you create the persistent volumes, it will create EBS volumes. And when you create ingress resources, it will create like application load balancer for your application. So this is a day-to-day, a traditional EKS cluster, right? And up still now, this is valid. People are using it. And let's now jump to your question. Cool. So you see the cards moved here and there now. And inside we have the EKS cluster, and EKS account side, like AWS manage. Now it's a bit different. They manage most of the stuff from the data plane, which are like as it is, like API server instances, etcd databases, and you see storage, compute, and load balancing. Okay, and we have another things like the core add-ons. So inside that managed capabilities, the networking also there. So which basically like core DNS, Kube proxy, VPC CNI also managed by AWS. So for the storage, like before if I go back quickly for the previous slides, the CSI drivers, and it will be managed by AWS, which is like comes under storage. The time we're recording this still support EBS volumes. I'm not sure when we upload this, there can be EFS also available. We don't know. So AWS rapidly updating these things, right? So
yeah. And then in terms of VPC CNI plugin, so I think it is at the moment for networking, it only supports VPC CNI, right? But as you said, soon there might be other networking plugin support as well.
We don't know, right? We may never know. Like AWS keep rapidly upgrading and enabling feature. They listen to customers, so we may never know. So there can be any options in the future. We can see customers would be able to pick it up. But currently, it's a VPC CNI, and yeah, for the networking. And the instance will be like initiated by Carpenter, and Carpenter will create the EC2 instance, which will be creating inside our account. You see, right? It's in the middle. So all those resources created by those add-ons, for example, like load balancers, EBS volumes, are stored in our account, which means we are paying for that. Cool. So, but all the things are managed by AWS side. So when I did this kind of a deep dive, and when I tried this out, I couldn't see any pods running. When I initially created the EKS Auto Mode cluster, I couldn't see anything like, Carpenter pods are running, nothing. But I could be able to see like node pools, node claims. Those are there, like when I'm scaling out any application. So recently, I spin up a EKS Auto Mode cluster using EKS CTL command. Then I noticed metric server is now by default inbuilt, but I'm not sure because it comes with the EKS CTL command itself. But I never tried through the control console. But when I created through the EKS CTL command, I noticed the metrics also now comes as a managed.
In terms of metric server, yes. So it comes as a managed add-on, because I did a bit of a proof of concept last week, and so even within console, if you go to custom mode, and like you select auto mode, but then if you go into customize, you can untick that option, but by
Okay.
default it is selected.
Oh,
And
good. I
and
didn't. I
also
didn't
there's
know.
a whole heap of whole heap of other managed add-ons as well where you can
Yes.
select.
Yes.
Yes.
So, I mean, to be honest, I didn't know about that. Like, thank you for sharing with me that. So I know, like, I think I should be able to pass a parameter in EKSCTL command, then I can. But definitely, if you need a cluster, definitely a metric server you need, right? If you're scaling out your workload. So yes, so definitely need it. So this is how simple, right? So how they manage it. So if you go a bit deeper, it's okay, right? If I go a bit deeper about that one.
Yes, of course. Yeah, because so I have a question around there. So you mentioned that there's if you spin up a cluster and if you don't have the metric server, uh, there's no worker nodes coming up. So how would you run these Carpenter pods and VPC CNI and kubeproxy, all these pods for the add-ons?
Cool. So you can't see those pods running, right? Like no daemon set, no SPS, or no deployment, nothing there. So Amazon manages that. Like, see, they are in their EKS account. They manage the Carpenter cluster. So how they run the Carpenter behind the scene, they run it. But VPC CNI, CoreDNS, CodeProxy, right? Those services are running as inside the worker node. System D level is runs as a service. So that's where the bottle rocket coming in. So bottle rocket OS, it's optimized for containers, right, Geetika? So that's the reason we are not allowed to SSH into the worker nodes. We can't. So it's totally immutable. It's totally immutable. So I think that's good because there are pros and
That's
cons.
good.
Yes.
So it is, yeah, one can argue it's a limitation that you can't
Yeah.
SSH into the nodes, but then if you're following best practices, you
Yeah.
shouldn't be SSHing into the worker nodes, right? So
Yes. So troubleshooting, we should have like add-ons like, for observability, you can have, CloudWatch contain inside, or third party tool like Neuralink, you can install it, right? So you can use those things to do the observability part of it. But production workloads it should be immutable. You shouldn't be touched. Once you deploy, that's it. If there's anything, go through a process, proper CI/CD pipeline, go through the testing, get the approvals, then only it should be shipped to production. You should be touching it. But here, you can't SSH into the worker node. Like you mentioned, people might have different opinions, but personally, I'm okay with it because I can get all the observability part from all the tools.
yeah, because as I mentioned, like if you're following best practices, then you shouldn't be logging into the worker nodes anyway, and then you're not losing out anything. The next question I have is when we talk about AWS, we can't forget about shared responsibility model, right? So for security or sustainability, they love to share the responsibility and define where the boundaries are. So how about the shared responsibility model for EKS and EKS Auto, pretty much?
At reInvent, they actually talk about this in depth, like how the shared responsibility model comes into the picture. So let's quickly check a traditional EKS cluster. That's what we usually get, right? Like we can see like 6 pillars here, and the top 3 managed by us, which are customers, and the bottom 3 pillars are managed by Amazon. So Amazon manage, as we discussed earlier, they manage the control plane, the API server, XANIs, and XC database, so on, and foundational services, right? They have to give the EC2 instances for us, the volumes for us, right? And the networking part, monitoring part, everything, they have to manage it. Like they should give those services. And global infrastructure, we are talking about the region, local zone, edge locations, and so on. Right? So if you go one more layer up, which comes under the manage customs and cluster capabilities. So previously we talked about the capabilities about scaling, the networking, storage, those capabilities, right? And the add-ons also we discussed about Carpenter, Cluster Autoscaler, VPC, and so on. So as customers, we have to install either a EKS manage add-on or a add-on which we are going to deploy via ourselves. For example, if you have GitOps like Argo CD, you can deploy using the Helm chart, deploy the Carpenter or like BPCNI or any add-on. Cool. So for the computer scaling and networking, load balancing, storage services, those are the main core things, right? And EC2 instances, right? Lifecycle is like you mentioned. We both know how crucial is security. So when Amazon release, for example, Amazon Linux AMI, usually Geetika, I think there will be like 2 AMI releases per month, if I'm not wrong, unless there's any security patches.
Yeah.
Usually about it like that. But if any high vulnerability, they always release a new AMI, so it can be more than that. So managing the AMI patch. So patching the AMI, if you're using either Cluster Autoscaler or Carpenter, it's not a problem. But how are you going to drain the old nodes and how it's going to happen, right? So it should be very it should be automatic way, but same time you have to respect the node disruption, pod disruption. There are so many things behind the scene. And operating system patches, and again patching, monitoring. For monitoring, you have to enable. We have to check the health check of the instance as well. So Amazon released a service to check your node health and auto recovery if there's any issue with the node health as well. So that is what the health and repair, right? So currently you have to check. Like previously, we had to check the EC2 instance health in the health dashboard, and you had to make sure the life cycle happening without any disruptions. And system agent, kubelet, container runtime. So if you're bootstrapping your own AMI, you have to take care of these things and take care of the VPC infrastructure. If you're planning your EKS cluster, make sure properly plan your network. Otherwise, you will end up in IP exhaustion and those things, and cluster configurations, and so on. So I think it's enough. We are talking about the traditional cluster, right? Let's move to next one. See, so before we had like Geetika, like 50%, right? Like we had like 6 pillars, and even now we have 6 pillars. But now Amazon manage 4 out of that 6 pillars. So even the cluster capabilities, computer scaling by Carpenter, for networking, network policies, elastic load balancing, storage drivers, and those capabilities covered by the add-on we ship with EKS Auto Mode. And cluster EC2 instances. So since it's running Carpenter and it respect node, it respect the pod disruption, it respect the node disruption, and you can customize your own disruptions, how the workload going to disrupt, and it will automatically do the life cycling and bottle rocket OS patchings. So it's a different topic we can talk about, how bottle rocket patch the operating systems and health and repair. And all of these are managed by Kubernetes Auto Mode now. And we have to still manage, because this is application ready cluster is Auto Mode, which doesn't mean that we are ready to go production, because we need to have production means it's what I meant by that different people have different requirements. So if you want to have like external DNAs, Let's Encrypt, certificate manager, those add-ons, definitely you have to manage your own add-on at the moment for now. And you have to make sure your networking, how you're configuring your networking, and the cluster configuration, and the monitoring, security, the application container availabilities, right? So it's customer's responsibility, right? So the key point here, you see, right? Within exactly less than 10 minutes, you can create a cluster which is application ready, and you have to have your Kubernetes manifest, Helms, or just deploy it. So let's compare the both. See,
Yep,
isn't it amazing?
it is. It is. So how does this help with all the cluster upgrades? Because I think that we can't escape cluster upgrades if you're talking
Yep.
about Kubernetes.
So cluster upgrades, still they have the same method of doing the upgrades. So you will be following the same way. But I have done in my testings, like upgraded a cluster from Kubernetes 1.30 to 3.1. So it's still it will the AWS take care of the control plane, the behind the scene upgrades. But then I notice Carpenter, it's something in Carpenter called drift detection. It detects, okay, the control plane version upgraded, and I have to deploy new nodes with the new version. And for my testing, I created some pod disruption as well, like, okay, 10% of available disruption only can disrupt my application. And within few minutes, when I was listing, like using the kubectl commands, I saw that new nodes came with the latest version. And when I check the namespace events, so it's respecting the disruption, and same time it's evicting the pods. And after a few minutes, all nodes are drained and deleted with the new node. So again, it's a shared responsibility. So application teams should make sure the application should be able to disrupt, and that way they have to write the application. Like running a single pod in a Kubernetes cluster, it's not going to help, right? So
Yeah,
make sure I
so
have
that
a
defeats the
number
whole
of
purpose of Kubernetes anyway, right?
exactly,
So
exactly, yeah.
yeah. So what are the use cases you see? Like what type of teams or what type of workloads can be run in this auto mode?
Yes, this is really good for so many things, right? Like if you have a platform, or if you have different teams. Let's talk about generative AI, right? Everyone talking about this is like Gen AI. And let's say you want to train your model on an EKS cluster with GPU nodes, and EKS Auto Mode, it support to do that. Because how? Within, as I mentioned, you can create a cluster within few minutes, and you can train your model once done, and automatically Carpenter will scale in your nodes, and you won't have a cost. So that's one of the example I would think about. And one other good option, like cattle class clusters. So within few minutes, you can create the cluster, you can run the test, and you can shut down. For example, if you want to run some test cases and run some workload, and just spin up a cluster, and everything is included in your IAC, like CloudFormation, Terraform. You once done, the cluster is destroyed, and so on. That's and the pod identity also come in built, right? So very easy to use it if you want to access your AWS resources in those things. Yeah, so those are really good examples as well. But if you're building a cluster from the scratch, this is a good place to start, because the capabilities are covered by AWS, and the instance cluster EC2 instance also covered, especially the patching and everything. And you can, top of that, you can start to build now.
Yeah, so that's good. And then you touch a little bit about cost. So that is my last question, actually. So what does the cost implications in this EKS Auto Mode? How much we have to pay for all these management overhead AWS is taking away from us?
Without cost, we can't end this session, definitely. So definitely people might have, what's the cost, right? So the pricing calculation in here, I'm just basically the case the page, and I'm just going below down. And before go ahead, let's go to our neighbor region, Sydney. And I'm scrolling down, and let's say Yes, EKS Auto Mode example here. So this is a key point to highlight. So see, right, EKS Auto Mode charge a managed fee that varies based on EC2 instance type launch, in addition to your regular EC2 instance cost and control plane cost, which means there will be an additional cost, a top part of the traditional EC2 instance when you're using EKS Auto Mode. So this is a really good example. Here, I think it's around like 10%, right, Geetika, for a
Yeah, I think it's
C6
about 10
clutch?
to 12% extra.
Yes.
So, yeah.
Yeah. So this is the total cost, for example, in this case, and you will be paying not only this one, but apart from adding this one. But keep this in mind, like AWS is taking care of a big pain like the nodes auto scaling, like Carpenter. So you don't have to worry about the version upgrading Carpenter, those things. You have to just write your all the node pool YAML files and configurations, and you can configure it. So um,
Yeah. Actually, yeah, in my opinion, I think it's a really good price to pay because if you think about it, you don't have to worry about, as you said, carpenter, and then you don't have to worry about all these basic add-ons and those management
yeah,
of those add-ons.
yeah,
So it's a good price to pay for taking care of all that away from you, right? So
yeah. So if you're going to wrap it up, like this is a really good. I mean, to be honest, I love this feature because it makes life easier, and especially like managing worker node, right? That is one of the pain point. And for the add-ons also, like an example, when you upgrade the clusters, you don't have to worry about upgrading those core add-ons because it's managed by AWS. They will take care of upgrading those add-ons as well, like which managed by AWS, right? So this is really good, really good. Like Gen AI is a big fuss these days, and if you want to train a model, I have seen already a lot of articles sharing, like community builders, heroes are sharing everywhere that how they train their model in a EKS cluster, which is created using EKS Auto Mode. So yeah, let's see how it's going to improve before this reinvent this year, right?
yeah, because I'm very much looking forward to more and more add-ons being added into AWS managed side. So and giving us more options. But yeah, sounds promising. Yeah, and yeah, I think we are at time, and let's wrap it up. So thanks for joining, and thank you for your time, Zach, and hope to see you again at some point in this podcast again. Thank you.
Yes, thank you. Thank you, Geetika, for inviting me for your podcast. And this is the first episode of you. And anyone who are watching this, I recommend. Personally, when I have a deep AWS discussion, I always go to Geetika. He's always there to help me with my either can be a personal or study or anything. So he's kind of a AWS guru for me. So definitely keep in touch and watch out for any new videos from Geetika.